Hi, we're going to finish our discussion on transplanetary characteristics by doing a quick review of planetary atmospheres. So if you recall, the atmosphere is the layer of gas that surrounds a planet, and a planet's atmosphere, the characteristics of it depend very heavily on a number of factors. One of the most important factors is gravity. Remember that the larger a planet is, the more gravity it has, and so generally that corresponds to how much atmosphere it has. Gas, being very light, is difficult to hold down, so a planet needs a lot more pull of gravity to hold down the lighter weight gases. The most abundant gas and just material in general in the universe is hydrogen and helium. And although they're very abundant in the inner planets, hydrogen and helium aren't all that common because they're so lightweight. It's difficult for the smaller planets to hold down. So when we do a quick overview of the planets, recall that Mercury, being very, very small, does not have enough gravity to hold down an atmosphere. Additionally, being so close to the sun means that the gas that's there is very hot, which makes it tougher to hold down, and solar wind blows a lot of that gas away. So Mercury doesn't really have much of a chance, even though there is some outgassing of atmosphere. Venus, you might recall, has a very, very, very thick atmosphere, 98 times as thick as Earth. That's not because it's larger. In fact, it's just a smidge smaller than Earth. But Venus has a constant expulsion of gas due to volcanic activity. It does have enough gravity to hold down most of the heavier gases, especially carbon dioxide. And so Venus keeps adding to it, and it doesn't have some of the other features that Earth has, which helps to remove some of that carbon dioxide, so it just keeps getting thicker and thicker. Because of all that carbon dioxide, which is a greenhouse gas, Venus is also very, very, very hot. Recall that Earth's atmosphere is mostly nitrogen and oxygen. The lighter elements like hydrogen and helium, once again, are too light for Earth to hold down. But some of those elements did mix with other heavier elements like nitrogen and carbon. And then because of dissociation of hydrogen, a lot of those turned into other atoms like silica, which is in our rocks, carbon dioxide, and water. Now, thankfully, because of Earth's temperature, the water is able to form a liquid. A lot of that liquid then dissolved the carbon dioxide, leaving us mostly with nitrogen, which was left over from the ammonia in the atmosphere, and oxygen, which is a result of photosynthesis. If Venus were cooler, some of the water it had might have been able to dissolve the carbon dioxide. Finally, Mars also has carbon dioxide from volcanic activity as well as from being a little bit of a heavier gas, but Mars is significantly smaller, and so consequently it can hold down less and has a very thin atmosphere. Additionally, it doesn't have as much protection from solar wind, so some of the atmosphere is lost due to that. The gas giants, first off, to talk about atmosphere and gas giants gets a little sketchy because remember, atmosphere is the layer around the planet that's gas. Well, gas giants are mostly gas, and so talking about atmosphere versus the planet interior becomes a little bit difficult to distinguish. But when we talk about the composition of the gas giants, they are significantly significantly larger, hence gas giants. So the more mass they have means more gravity, which means that they can hold those lighter elements down. So they're mostly hydrogen and helium. There's other stuff present. For example, Jupiter and Saturn are yellowish in color because they also have ammonia from the hydrogen mixing with nitrogen. But by and large, it's hydrogen and helium. The temperature affects whether that hydrogen and helium is gaseous, liquids, or ice. So in the outermost planets, Uranus and Neptune, some of that hydrogen has turned into ice particles, like our high-level clouds, the cirrus cloud. When we look at the outer planets, you may notice that there's a significant amount of banding in the planets. That banding is a result of their quick rotation. Jupiter and Saturn both rotate very, very quickly, faster than Earth does. And being that they're made of gas and moving very quickly and being much larger means that the different portions of the planet are moving at different rates. The gas near the equator of the planet is spinning much, much faster than the gas near the poles. Additionally, heating from inside the planet, much like we have rising and sinking of air that causes our weather, that happens as well on those gaseous planets. And so as air is in the interior, it becomes warmed by the interactions with the deeper layers, it becomes warmer. That warmer becomes less dense. It rises, and then as it cools, being near the surface, it sinks back again. That creates also difference in color because of the heat, as well as the banding appearance. So when we combine those two, the rotation and the convection, that's what causes planets. Looking at the four outer planets, we really have two sets of twins. Jupiter and Saturn are very similar, and Uranus and Neptune are very similar. Jupiter and Saturn are the very biggest, which means they have the largest percentage of hydrogen and helium because they can hold those light gases the easiest. They also, because of their size and fast rotation, have the most amount of banding. Uranus and Neptune, being smaller and colder due to their distance from the sun, have lots of hydrogen and helium, but their size means that they also have more methane because it's a heavier gas. It's easier for them to hold down. The fact that they have methane gives them a blue appearance, just like the fact that Jupiter and Saturn had a little bit of ammonia gives them a yellow appearance. Sometimes Uranus and Neptune are called ice giants because a lot of the gases at the outermost layer, much like the very high clouds in our atmosphere, have ice particles in them. We look at the other objects, we've already talked about them, so this is just review. The other objects are very, very small, and so most of them are too small to have any kind of atmosphere whatsoever, just like Mercury. There are some exceptions, though. One of them would be a comet. Remember, comets are covered in ice, unless they come into the inner solar system when that ice would be vaporized. Because they're not in the inner solar system long enough for that ice to become vaporized and completely leave the comet, when they move away from the sun, the ice refreezes. So they have a temporary atmosphere. There's some other exceptions, such as Saturn's moon Titan, which has an atmosphere as well. We don't always understand, though, where that atmosphere comes from, so we're still learning a lot about Titan as a moon. As I mentioned, with the gas giants, it's very difficult to distinguish the boundary between what is atmosphere layer around the planet and what's the planet itself. Additionally, as we get further and further away from the planet, there's less and less gravity, so the atmosphere becomes thinner and thinner and thinner. We call that outermost layer the exosphere, and at that level, the molecules are so far apart that where there's space versus where there's a molecule here or there orbiting a planet gets a little sketchy too.